Hello and welcome. This lecture is on Introduction to Physics. Physics deal with the nature of things, the things with which we concern ourselves in science appear in a variety of forms and with a multitude of attributes. Human nature demands that we seek answers to the basic questions. For example, we may ask why the wind flows, we may be perplexed by the question why the waves in the sea break, we may also be perplexed by the question how the birds are afloat in the air, and we may have several different types of questions. These multitude of aspects perhaps results from the action of a relatively small number of elemental things and forces acting in an infinite variety of combinations. For example, flowing of the wind and the flowing of the water in a river may be governed by same set of laws, or all the solids behave in the same way. Now, what is a scientific method? Science is a systematic attempt to understand the natural phenomena in as much detail and depth as possible, and then use the knowledge so gained to predict, modify, and control phenomena. The science is exploring, experimenting, and predicting from what we see around us. Observation, reason, and experiment make up what we call the scientific method. The universe that we live in is governed by laws, and we are merely the observers of the universe. Now, what are the rules governing the universe? The rules by which the universe is governed is not known to us. But if we observe for long enough, we can make an intelligent guess on these rules as the events of the universe slowly unravel itself to us. There is no point in the time that we humans can claim that all the rules by which the universe is governed is known to us. We are also limited by our ability to explain natural phenomena in terms of these rules. This is because almost all situations are so enormously complicated that we cannot follow what is being unfolded in the universe using these rules. Therefore, our ability to predict the future is also very limited. Therefore, fundamental physics limits itself to finding the rules of the universe. If the rules are known, it is considered that we have understood the world. Now, how can we tell whether our guess of the rules are correct if we do not know all the rules? This can be done in three different ways. We can arrange the nature to be simple and to have so few parts that we can predict exactly what will happen, and thus we can check how our rules work. This is what is called experimenting in the controlled environment. So to check a particular rule, we design an experiment, and to isolate the experiment from all other external disturbances, we conduct the experiment in a controlled environment which is free from external effects. A second way is to check rules in terms of less specific rules derived from them. The basic rules of physics are universal. the same laws apply in widely different contexts. Therefore, the same experiment we can conduct at different locations with different conditions to check their validity. The third way is by rough approximation, by extracting essential features of a phenomena from its less significant ones. So in an experiment, we take only those aspects of the phenomena which are having maximum impact on the output, and we neglect those phenomena which are having least impact on the output. This is called the rough approximation. Now, how can we divide the phenomena of nature into classes? Or alternatively, we can ask the question, what are the classes into which the natural phenomena is divided? So we can divide the natural phenomena into classes of heat, electricity, magnetism, mechanics, properties of substances, chemical phenomena, light or optics, gravitation, etc. However, the aim is to see complete nature as different aspects of the same phenomena. Thus, the problem today in theoretical physics is to find laws behind the experiment in order to blend these classes. For example, the kinetic theory of gases says that more atomic motion means that more heat is added to the gas. Thus, heat and temperature can be represented by laws of mechanics. Therefore, the kinetic theory of gases is an amalgamation of mechanics and heat. Similarly, electromagnetic field theory is an amalgamation of electricity and magnetism. The question therefore is it going to be possible to always blend everything and discover that this universe represents different aspects of one single thing? The aim of the physics is thus to see what are things made of and how few rules are there. The entire syllabus of class 11th and class 12th in CBSE and IIT-JEE entrance exam is divided into following parts. It is divided into general physics, mechanics, thermal physics, electromagnetism, optics, modern physics, and semiconductor physics. In general physics, units and measurements are included. In mechanics, motion in a straight line, in a plane, and laws of motion are included. It also includes work, energy, and power, system of particles and rotational motion, gravitation, mechanical properties of solids and fluids, waves and oscillations. In thermal physics, thermal properties of matter is included, as well as thermodynamics and kinetic theory. Electromagnetism is divided into further two subclasses, that is electricity and magnetism and EM waves. In electricity and magnetism, electric charges and fields, electrostatic potential and capacitance are included. It also includes current, electricity, moving charges and magnetism, as well as magnetism and matter, electromagnetic induction, alternating current. In EM waves, principles about the electromagnetic waves are taught. In optics, ray optics, optical instruments and wave optics are included. In modern physics, we are taught about dual nature of radiation and matter, as well as about atoms and nuclei. In semiconductor physics, semiconductor materials, devices, and simple circuits are taught.